current physics is not well defined for magnetic field. So when you not well define something, you cannot use it because you don't understand how it works. Okay, I got a magnet here under this cardboard and iron filament. You can see the magnetic field, and right there, it flows from one pole to another pole. And let's take a look at NASA version of Earth. It flows from the north magnetic to the south, which is the south magnetic is the north geographic. So that's the flow. Right? The main point here, this video is how this light bend. Physics, before you use this, you need to explain how. What is the mechanism for bending this? See, if you have a photon light, electromagnetic, out in the open, it's going straight. Here, it's bent. And of course, if there is a kind of weak explanation or attempt to explain, it would be it bent itself. Well, again, then if that's the case, then I can lift myself and levitate. But also, per VP, previous video, it's to go to the density wise, it's to go to high density, and then low density, back high density. Again, that is the problem with the logical consistency in terms of you cannot have high pressure, go to low pressure, and go back high pressure without work. Again, not only couldn't explain how the light bend, also you talk about energy issue, work involved. So anyway, so this is the problem. And right now you're probably thinking, it's always that way. That the line and everything else. And so this Earth, the big one, and this little guy here, and the curvature very tight. That means something influenced very strongly. If light go close to a very massive object, then it will curve based on gravity, very slightly. It curves in a long way distance. But this here, it's curved drastically. So that alone disqualifying the certainty or the for sureness of physics of able to use something in order equation and everything else. You can fundamentally, you're not defined in the fundamental aspect of it. And now here's something that manifests from didn't do well in the first place. Take the magnetic dipole moment. So Maxwell will define it. Say, okay, you have here this object Earth or an electron here in the field. Earth will be in the magnetic field of the sun. So there will be a field of torque from the sun magnetic field. If you use Maxwell equation, then you have only half the torque. But then you have to use Dirac. Of course, the introduction of quantum, then you double it. But in other words, it's off by 100%. When, if you were going to launch something and you're off by 100%, then you're going to crash. And then when you talk, and then the fine tune after they patch it with the Dirac equation, then you patch it again with the quantum electrodynamic, talking about the Lamor Precession, and so therefore, but that factor is only 1,000 of a percent. very, very little. Yes, you can add, you can call it fluctuation or uncertainty or quantumness or whatever, that little amount. So if you were going to try to go to Mars, yes, you would land on Mars without that little percentage perhaps, but you go to Pluto, you might have like just that little percentage of angle perhaps. But that is quantum. Okay, if you use it as a convenient way to describe precession of something, sure. But not when the original equation, the magnetic field here, I can touch, telling me that this whole calculation is out by 100%. Therefore, that equation is just wrong. The whole concept needs to be fixed in a big way, not by patching and then somehow you call it G-factor in the Dirac equation. That's just like whatever with 3 or 5 or 3.5 or 7. But as far as the field, I think in my previous older video, all you have to do is add a field also flow from south to north. So you have concurrent. The flow is bidirectional. I can go into more in depth exactly how this light curve and why the torque is 2 times. But until this bending of this field is actually you actually recognize the problem. Otherwise, again, I mean, I'm afraid that it's a futile process if I try to bring a solution when you don't see the problem. All right, thanks for watching.